All right, guys, this is probably going to be a pretty long video. It is going to be a combination of, not a combination, just many, I think there's like 9 or 10 total that I'm going to verify in this one video. And these are the simpler trig identities, and that's how we start. We start with the simpler ones and the ones that it's easier for us to actually see kind of what we're supposed to be substituting. So here's the deal. When you're doing trig identities, you start with the complicated side, and by complicated side, I mean just something that has more on it. The left side versus the right side, it doesn't really matter. It's just the one you want that has more, because you need a little bit more. It's easier for you to start with more and whittle your way down. You are only ever going to work on one side at a time. Like if you pick the left side to work with, that is the side that you stick with and choose, and that's where you're going. And then ultimately when you simplify everything, it should be down to equal the other side. Usually, but not always, you are going to try to rewrite things in terms of sine and cosine. And you are going to use that lovely trig identity sheet to see what you can substitute in. Okay? Verify that cosine of theta times the secant of theta equals 1. So I am going to stick with the left side just because there is more on it. So I'm rewriting the left side. You always start with rewriting the left side, or rewriting whatever side you're working with. And this is me being me and asking you to do this, and quite frankly demanding that you do this. And then ultimately, so cosine of theta times, now sometimes you guys, when I'm making these videos, I won't write the times in there just because it's a little bit of a pain in the butt. So then what you're going to do is you're going to look at your identity sheet, and you notice that cosine of theta is already cosine of theta, so you kind of leave it alone. And then if you look and you see under your reciprocal identities, you'll see that 1 over secant is the same thing as 1 over cosine. I'm sorry, secant of theta is the same thing as 1 over cosine. Was jumping the gun on that. And then ultimately, cosine on top, cosine on the bottom, that cancels. And I mean, if you need to, you can write it over 1 so that you kind of see that that's what's happening. But they cancel because you got 1 on the top, 1 on the bottom. So hey, the left side in one quick step is equal to the right side. So then the next one is pretty lame. So we've got sine of theta, and I'm starting with the theta times the cosecant of theta, there we go. Right? And you leave the sine alone because it's where it needs to be. And then you're trying to do this, and cosecant of theta is the same thing as 1 over sine of theta. And again, you can put this one over, I meant to change colors. You can put this one over 1. You're multiplying two fractions when your numerator and your denominator are the same thing. They cancel out. You get a 1. I shouldn't say cancel, they reduce. Okay? So pretty straightforward for that. Let's go to the next. All right, cosecant and cosine. We want to make that equal to cotangent. And again, I'm starting on the left side. You're not always going to start on the left side. It just so happens that there's more on the left side. There's 2 items to deal with rather than just 1. And again, I'm going to leave that cosine alone, but I am going to change that cosecant. That cosecant is the same thing as 1 over sine of theta. And you're doing times cosine of theta. And I'm going to put it over 1, just so you remember it's over a 1. And here's the thing. This particular fraction doesn't have anything that reduces. So cosine of theta over the sine of theta, hey, guess what? If you look at your identity sheet, I don't remember which one it is, blah, 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 blah. Oh, it's the tangent and cotangent identities. So the 2 at the top. All right, and you'll see that this lovely fraction right here is the same thing as the cotangent of theta. Okay, so once again, you took one side of the equation. In this case, we started with the left side. We did a couple of steps here, and we got the right side, which is what you're looking for. Onward and upward. All right, so cosine of theta over sine squared theta. We want to see if that can verify to equal cosecant of theta times the cotangent of theta. All right, here's what we got. And I am going to do something that you don't necessarily have to do. I mean, well, I think I did when I did the PDF. You know what? Let's do it. I'm going to start with the right side. So we're going to do that. Okay? And you could have very easily started with the left side, and that's the thing about this, is like, it doesn't matter. You can start with either one. So I'm going to start with the right side. I'm just writing it, cosecant of theta times the cotangent of theta equals, all right, and then cosecant is the same thing as 1 over sine, right? And cotangent is the same thing as cosine of theta over sine of theta. Okay, so now I am multiplying these two things, and obviously the numerator is 1 times cosine, and that is just cosine theta. And then when you have sine times sine, think of them as variables. Like when you do x times x, it's x squared. When you do sine times sine, it is sine squared. Okay, and that verifies that one. I think I do a couple others where I actually start with the left side on that one, but either or works. All right, there we go. On to the next one. Okie dokie. 1 minus cosine theta over sine theta. I'm going to start with this side again. Do something a little different. Okay. So we've got cosecant of theta minus the cotangent of theta. Okay. And that is going to equal cosecant of theta is 1 over sine theta. Okay. And cotangent of theta is cosine theta over sine theta, and we are subtracting them. Okay, we are subtracting them, and they have the same denominator. When two fractions have the same denominator, I can actually just write them as 1. 1 minus cosine of theta over sine of theta, which is exactly what I wanted. Now, that being said, I'm not going to write it, but I'm going to talk it through. If we had wanted to start with the left side, okay, literally you would have written this, and then again, I can't stress enough, you have one fraction, there is a subtraction or addition, like it doesn't matter, it's either addition or subtraction. You can actually split that, right? You can split that into 1 over sine, which is this, and cosine over sine, which is this one, and then you could have gone backwards, okay? And I didn't do it on the last one. I started on the right side instead of the left side. You can also split it, and I'll just do this real quick over on the side over here. Like if I had, I think the last one. No, it was cosine over sine squared, right? To go and do the other one, I actually did cosine over sine times 1 over sine, okay? That's how you would have actually worked from the left on the previous example. Sorry to kind of, throw that in there. Should have done that when I was doing that example. All right, heading on. Okay, so let me switch back to red. I'm going to start with the left side again because I've got more on there. So oopsies, didn't want to do that. So starting with sine of theta over 1 minus cosine squared theta. If you look in your Pythagorean identities, okay, here's the deal. Your Pythagorean identities, there is and I'm going to do this in blue off to the bottom, not to the left. So your Pythagorean identity, and I'm leaving the theta off just to keep room. Sine squared theta plus cosine squared theta equals a 1, right? That is your Pythagorean identity. That's the very first one that's listed. If you subtract cosine squared from both sides, you will see that sine squared, right, equals 1 minus cosine squared. So I'm actually going to take this 1 minus cosine squared and plug in a sine squared. So I've got sine, of theta over sine squared theta. Okay. Now, in the previous example, I said treat it like it is, like they're variables. If you had x over x squared, the x on top would become a 1, and the x squared on the bottom would no longer be squared. It'd be 1 over x, right? Well, same thing applies. So this is 1 over sine theta. And again, if you look at your reciprocal identities, 1 over sine theta is the same thing as cosecant theta. So that is verified. Okay, almost done. I'm going to do basically the same thing. If you look at your Pythagorean identities, and I apologize because I think that the paper hole punch actually took that out of there, it cut it out of there. If you start with your left, cosecant of theta, okay, over 1 plus cotangent squared theta, and you have to write the original as is because I need to know what side you're starting with, okay? This 1 plus cotangent squared theta is the same thing as cosecant squared theta. So I've got cosecant theta over cosecant squared theta. And again, we've got things that are reducing. This becomes a 1. That is no longer squared. So this is a 1 over cosecant theta, which is, of course, sine theta. Verified, and here we go. Goodness gracious, I was done. Okay, cotangent theta over cosecant squared theta minus 1. And again, if you look at your Pythagorean identities, it's really, it's listed as 1 plus cotangent squared theta equals cosecant squared theta, right? Subtract 1 from both sides so that cotangent squared theta equals cosecant squared theta minus 1. That's what I'm going to use. Cotangent. All right, so here we go. Cotangent theta over cosecant squared theta minus 1 equals, all right, again, what I just did down there in blue, cosecant squared theta minus 1 is the same thing as cotangent squared theta. Okay. Oops, and that's still over the cotangent theta that I already had. And of course, that becomes a 1, that's reducing. So I really have 1 over cotangent theta. If you look at your reciprocal identities, that is tangent theta. Okay, I think we have 2 more. I think 10 and 11, yeah. Okay, starting with left side. This one's kind of nice. Okay. You've got 9. Oh, okay, maybe not. You've got 9 minus, let me change, there we go. 9 minus cosine squared theta minus sine squared theta. Okay, and that's going to equal. Now, what I'm going to do is really, I'm just going to factor out a negative 1. So I've got a 9, and you've got minus out here, and I'm factoring that out. So really, the only thing that happens is it becomes cosine squared theta plus sine squared theta. And if you look at your Pythagorean identities, that cosine squared plus sine squared has to equal 1. So this is really 9 minus 1, which, guess what, guys? Please don't plug that into your calculator. 9 minus 1 is 8. All right, last one. I'm going to start on the right side. So we've got 1 minus cosine squared theta, and we are squaring that, times the sine theta. All right, here's the deal. In your Pythagorean, I'm throwing all of my pencils and pens everywhere. Sorry about that. In your Pythagorean identities, you will again see that sine squared plus cosine squared equals 1, right? And if I subtract cosine squared from both sides, I see that sine squared equals 1 minus cosine squared. Okay, so that's what I'm going to use because that's sitting right there. So 1 minus cosine squared is the same thing as sine squared. Okay, now that was still squared, and you are going to multiply it by sine of theta. Guys, I'm going to go purple for this one. If I had x squared and I was squaring it, I actually add my exponent, right? So this would be x to the 4th. Okay, I apologize, that's not right. You multiply them. Sorry about that. Yes, because, yes. My problem is I did 2 and 2. So if I had x squared to the 3rd power, it's x to the 6th. There we go. You multiply those exponents. And so ultimately, here you go. You've got sine to the 4th power times sine to the 1st power. And here, my lovely students, is where you are adding. Sorry about that. So sine to the 5th power of theta, and you got those. Okay? Gosh, I hope this thing isn't like 20 minutes long.